Joint variation. We now understand the concept of joint variation by solving the following word problems. Exercise 6.8. Question 1. The area of a triangle varies as its base and height. The area of a triangle having base 6 centimeters and height 4 centimeters is 12 square centimeters. Find the height of the triangle whose base is 8 centimeters and area is 36 square centimeters. Solution. Let the area of triangle be A, base be B, height be H. Since A varies directly to the base, we write symbolically as shown. Since A also varies directly to H, we write symbolically as shown. Combining both variations, we write symbolically A varies as B into H. So, A is equal to K into BH, where K is a constant of variation. Now we know A is 12 when B is 6 and H is 4. Let us substitute and find K. Therefore, 12 is equal to K into 6 into 4. Therefore, K is equal to 12 upon 6 into 4. We get K is equal to 1 upon 2. Hence, our equation of variation is A is equal to half of BH. Now it is simple to find H when B is 8 and A is 36. We first substitute the values in equation of variation. A is equal to half of BH. Therefore, 36 is equal to 1 upon 2 into 8 into H. Therefore, 36 into 2 upon 8 is equal to H. Therefore, H is equal to 9 centimeters. The height of the triangle is 9 centimeters. Question 2. If x varies directly as y and inversely as z, and if x is equal to 8 when y is 5 and z is 3, then find y when x is equal to 12 and z is equal to 4. Solution. We first write the variations symbolically as x varies directly to y and inversely to z. Therefore, jointly, x varies as y upon z. So, x is equal to k into y upon z, where k is a constant. Let us find the value of k by substituting x as 8, y as 5 and z as 3. On substituting, we get 8 is equal to k into 5 upon 3. Therefore, k is equal to 8 into 3 upon 5. Therefore, k is equal to 24 upon 5. Therefore, equation of variation is zx upon y is equal to 24 upon 5. Now, substituting x as 12 and z as 4 to find y. On substituting the values, we get 12 into 4 upon y is equal to 24 upon 5. Therefore, y is equal to 12 into 4 into 5 upon 24. Therefore, y is equal to 10. Question 3. The weight of metallic solid sphere varies as the density of its material when its diameter is constant and varies as the diameter when density is constant. A sphere having density 2.1 gram per centimeter cube and diameter 2 centimeters. Weight 2.2 grams. Find the weight of a sphere whose diameter is 1 centimeter and density is 6.3 grams per centimeter cube. Solution. Step 1. Let the weight be W, density be D and diameter be X. Therefore, W varies directly as D is written symbolically as shown. W varies directly as X is written symbolically as shown. We therefore express W varies jointly as X into D. So, W is equal to K into D into X, where K is constant of variation. We substitute W equal to 2.2, D as 2.1 and X as 2 and find K. W is equal to K into D into X. Substituting the values we get 2.2 is equal to K into 2.1 into 2. Therefore, K is equal to 2.2 upon 2.1 into 2. We get K is equal to 11 upon 21. So our equation of variation is W is equal to 11 upon 21 into D into X. Now, substitute X as 1 centimeter and D as 6.3 centimeters to find W. The equation of variation is W is equal to 11 upon 21 into D into X. We then solve for W and get it as 3.3 grams. Question 4. If X is equal to A plus Y and A is constant while Y varies directly as Z, X is equal to 30 when Z is equal to 6 and X is equal to 24 when Z is equal to 2. Find X when Z is equal to 10. Solution. We first write the variation for Y and Z as Y varies directly as Z. We get Y is equal to K into Z, where K is a constant. We now substitute for Y in equation X is equal to A plus Y. We get X is equal to A plus KZ. Substitute X is equal to 30 and Z is equal to 6. We get 30 is equal to A plus 6K, which is equation 1. Next substitute X is equal to 24 and Z is equal to 2 and get 24 is equal to A plus 2K. Let us mark this equation as 2. We have two variables A and K, whose values can be determined by solving the simultaneous equations 1 and 2. Subtract equation 2 from equation 1. We get 6 is equal to 4K. Therefore, K is equal to 6 upon 4. Therefore, K is equal to 3 upon 2. Substitute K as 3 upon 2 in equation 1. We get A is equal to 21. Hence, we got K as 3 upon 2 and A is equal to 21. We substitute values of K and A in the original equation, which is X is equal to A plus KZ. We get X is equal to 21 plus 3 upon 2 into Z. Now, find X when Z is 10. Hence, substitute for Z. Therefore, X is equal to 21 plus 3 upon 2 into 10 is equal to 21 plus 15. We get X as 36. Question 5. If x square y square plus k square is equal to 2kxy, where k is constant, then prove that y varies inversely as x. Solution. Now students, to prove y varies inversely x, remember we have to prove xy is constant. Let us use x square y square plus k square is equal to 2kxy to find the value of xy. We get x square y square minus 2kxy plus k square is equal to 0. Now this expression is like a square minus 2ab plus b square is equal to 0, where a is xy and b is k. We use the identity a square minus 2ab plus b square is equal to a minus b the whole square and write xy minus k the whole square is equal to 0. Taking square root from both the sides, we get xy minus k is equal to 0. Hence we get xy is equal to k, which is constant. Students, we have proved that xy is constant, so y varies inversely as x.